So I'm James Whittaker. I am an engineering director here at Google. Not here at Google, but in Kirkland and Seattle. And engineering directors at Google, our responsibility is to take credit for the work of people who are smarter than we are. And I excel at this. And generally, I don't even talk about those people who I take credit for their work because they're never in the audience. But today one is. And so I just want to, kudos to my friend Joel Hynoski. Joel, wave everybody. Besides being my bodyguard, Joel is also works very hard to see that I get credit for all of client testing at Google. That's Chrome operating system, small things like that. And the other thing I do with my time is I take credit for people who write cool tools. We call it engineering tools, and I have a couple of teams that do IDE work, dev work that developers consume, and I have another team that does ITE work, integrated test environments, which you're going to see a little bit today. So since this is the closing, I would like to say this has been a really good experience. The keynotes, Bob and Jeff, you guys were awesome. I thought it was really cool that we had an academic and a consultant who's, I think, his major customer is Microsoft right now, come to this conference. It was a good change of pace. I think that GTAC is special for a lot of reasons, but one reason, this is the only conference I have ever been to in 25 years of going to conferences. Okay, am I really that old? Okay, let's say 15. Let's call it 15. Where people stay till the end. I mean, have you ever been to a conference where you're at the end of day 2 and there's actually more people here than were here yesterday? I think that's pretty amazing. So, Sujay, the committee, you guys have done a great job, and cheers to you all. And I have to admit, I have to thank the host country of India, because I didn't actually jump with joy when I found out GTAC was going to be in India. I'm just going to be honest. I did not know what to expect my first visit to this country, and I can say now, truthfully, that I was not disappointed. And some cool things have happened these 2 days. We had a demand from our Turkish embassy for building good tools. And it was the right time to say that, Vasilis, because you've got Microsoft here, tool builders, you've got Mozilla tool builders, and you've got Google tool builders. So if we don't listen to you, then try again next year. So I'm here to turn quality on its head, because I've sat here through all of this, politely, mind you, listening to all this kind of testability love. And before I turn that on its head, I'd like to just talk about some common ground. I was a professor for 10 years. I got my chalkboard with me today. A little bit of common ground that we can all agree on. Just the fact that we're all here at a test conference, we are all implicitly agreeing, explicitly agreeing, that software just isn't that good. There's bugs in software, all software. Coding is complicated. Coding is error-prone. No one gets it right except Tracy and Russ. And I'm going to call you Tracy and Russ because everybody else calls you Russ and Tracy, and I just want to be different. And so instead, really, we should just be trying to, duplicate Tracy and Russ as opposed to testing software, because I submit this is an endless endeavor, especially the way you guys want to do it. You guys want to take something that we all admit is fundamentally flawed, the process of writing software, really complicated, incredibly error-prone because humans are doing it, and stick with me here, you want to solve it by writing more code. Interesting. So then we're going to have another GTAC, the Google Test Automation Conference for Test Automation, because the test automation rewrite is going to be buggy. This is an infinite regress. There is a fundamental problem with what we're doing here, with the theme of this conference. But let's look at the facts first. Let's figure this out. Let's have a contest between dev and test, writing code and testing code, and see what we end up with. Now, at Google, testers are sorely outnumbered. Some teams, 4 or 5 to 1, some teams 10, 12 to 1, some teams, who knows, 15, 20, it all depends. Now, how do we get by with this? Because this sounds atrocious. I know there's a lot of Microsofties in the audience, and somebody had a quote, I think it was Jeff from Bill Gates, that said, we have a developer for every tester and a tester for every developer. How do we get by with this at Google? We get by with this by having our developers do lots and lots of testing. In fact, the general rule is that an SET, a software engineering test, will write a framework, but the test cases for that framework will be written by the dev team. So we have these huge dev teams, and we have these little bitty test teams, but we got the devs doing a lot of the upfront work, right? They're writing unit tests, they're doing TDD, they're writing test cases for the automated frameworks. This is a lot of code that's going into test. I call this early cycle testing. On the other hand, we have test engineers and some contractors who do late cycle testing. Some scripting, some manual testing, but this is when the product is more mature, later in the cycle. So I want to just let's have a little contest. Right now it's dev test, nil, and let's see where we're going to invest. Now, I'm not going to say the winner gets all the money and we got to stop doing the other. That's not what I'm doing here. This is Google. We've got some change in our couch cushions. If I'm going to make an additional investment in testing, where is it going to be? Early cycle or late cycle? That's what I want to talk about. So, we all know that you can't test quality in, right? You put lipstick on the pig, it's still a pig. Only thing you can do is turn it into bacon. So, the whole idea of testing, pick your worst product ever. Pick the product that you hate the most. Pick the product that you cuss the most. More testing ain't going to help it, right? Refactoring, redevelopment, throwing it away and starting over. It's development that fixes problems. Test doesn't fix problems. So if you want better software, you got to write better code, and this is a development task. 1-0 dev. There is nothing we can do about this. Nothing we can do in late cycle that will really fundamentally improve a broken product. We can find some bugs, but the devs are going to have to fix them. We can totally prove that it's crap, and it'll just be crap. 1-0 dev. Sorry, test. Now, someone else produced a slide earlier today that showed how much bugs cost. They don't cost hardly anything if you realize as you're writing the bug, you realize it's a bug, and you just fix it right there. No cost, right? There's no bug report. There's no time lost in debugging. There's no rebuilding involved. It's free. And as you go, I think the number that just shocked me was like 500x, right? 500 times the cost in late cycle testing. And we've done some things to make that cheaper, right? We were all looking for, it was funny, when we were doing the exercise, we were looking for the bug on our little badge things. I was sitting next to Ted, and Ted's looking at it online. He's right, there's no bug. There's no bug. This is perfect, right? The bug had been fixed, but not on the printed versions, right? We don't do much printing of software and distributing it that way anymore. We do it in the cloud. So the cost has come down, but certainly there's more cost late cycle. Nothing you can do about it. 2-0 dev. Because even in the late cycle, even if there's no additional cost, you can just fix it really quickly in the data center and pump it out to all users for free. There's still loss of reputation. There's, that bug has to be debugged, and it could be that the developer who wrote that bug wrote it weeks ago. And weeks in developer years is like, a century. They've forgotten about it, right? They got to get it back inside their head. Lots of time, lots of money. 2-0 dev, sorry test, can't help you. This is the thing that really, really makes me mad at testers. They create throwaway stuff. They do, all the time. You write a test plan. How many of you are right now working on a test plan that is an exact execution of what you're doing, a representation of what you're doing, and an exact representation of the product that's being built? That's what I thought. I walk around the halls of Google and I see dead test plans. Remember this little boy from The Sixth Sense? Right? I see dead people. I see dead test plans. They're all dead. It's like a graveyard at Google. You write a test plan. Why do you write a test plan? Because you're told to write a test plan. You're not doing it to solve any real fundamental issue. Are you really planning test strategy in that test plan? Are you really designing all your automation and figuring out all your manual test cases? Really? It looks to me like a Kix document or Word document for you, Sam. It looks to me like a document that describes kind of some touchy-feely stuff about our product's got some stuff in it, and we're going to do some stuff to it, and here's a big long list of it. And you write these things hoping that they'll fool people, hoping that you can write it and give it and show it around to people, and the people will say, yeah, all right, you wrote the test plan, now go off and start testing. And then you go off and start testing, and what happens? Do you use the test plan? Do I walk around and see testers with 2 screens? We all have 2 screens at Google. Some of us have 4, right? 2 screens where the test plan's on one and the app you're testing's on the other, and it's guiding your every step? Only in my wildest dreams. I have these dreams, and I wake up in a cold sweat, and I think, oh, that was great. If I could only go back to sleep and retrieve it. People writing usable test plans and using them. Sorry, 3-0 dev. Test, you're down. 3-0. It's halftime, and you're getting your ass kicked. Oh, my God, I'm starting to agree with you people now. Yes, let's write a bunch of test code up front. That's the way to do it. Is there any hope for test? They're creating dead documents. They're finding bugs long after the code has left the dev's head. Too expensive. What are we going to do with these people? Fire them all. Now, why do I even have hope for late cycle testing? What is it that makes me think that this is something that we should do at all, that we should invest in at all? Because I have dev directors who I partner with, right? I'm the test director for Chrome operating system. There's a dev director for Chrome operating system. If I walked up to Linus Upson and said, Linus, you got 2 choices. We can delete all of our automation and stop writing auto test cases, or I can fire all my manual testers. You pick. I know in my heart of hearts that he would fire the automation. I know it because he's told me he would, because I asked him. I asked them all. They cherish manual testing. The devs. Now, they're not proud about this, right? And Linus is going to throw me under the bus if he ever watches this on YouTube. They're not proud about it. When they ask for more manual testers, they whisper, don't they, Joel? Right? Joel, can you get us 10 more manual testers? Right? And Joel's like, hey, James, guess what Linus wants? And then, of course, we like to broadcast this out. Joel's sending out emails to, dev all. Hey, man, we're looking for 10 more manual testers for Linus. They don't like to admit it. But they know in their heart of hearts there is some very valuable stuff going on there, right? There's recall class bugs being found by people sitting down using the stuff. People with minds, people with fingers, and people with eyes. So there's something there. What is it? So this is the way I think about it. I think about software as a forest. I like to hike. I go out in the woods and I think about ideas to write. All my books have started in the woods. Now, in these woods, the developers grow trees, right? They have a slice of the product. And there's nobody on the team that understands that slice of the product better than the dev, right? All the way from the UI, all the way down to the bowels of the system. Nobody who understands it better than the dev. And there's no question that the person most qualified to test that code is the dev. They understand it better than anybody. Why would you hire a tester to test the code that the dev just wrote? Stupid. Devs grow trees. Now, if I want to make an investment in early cycle testing, maybe I could get the tester to help water those trees. But this doesn't make any sense. Testers don't want to water trees. Testers want to chop them down, right? This is why. I mean, we don't hire testers because they can't write code. Our testers can write code. We hire testers because they want to break stuff. They want to write code that breaks stuff. They want to use their fingers to break stuff. This is their passion. We don't want them to help water the trees. What I need them to do is scenarios like this, and I'm going to score a goal for my tester here, because this is where a developer's ability to test completely falls down. They're great at watering their own tree and caring for it. But when you start to put other trees up next to them that they have to interface with, all of a sudden there's a lot of integration scenarios that the developer doesn't see. That's code they don't understand over there written by that other dev. And you don't want the other dev testing it either. In fact, I don't even think you want the two devs together testing it. They're just going to confuse each other because they don't want to do that. We don't hire devs because they have a passion for tests. We hire devs because they want to sit at their desk and write code. Bless their hearts, I'm glad somebody does. This is what we need testers for. The testers are going to see these scenarios. They're going to bring an independent mind, independent thought, and they are going to find the bugs that either of those two devs, and then you add 3 and 4 and 5 and 6 and 20 and 115, and it gets more and more complicated, and you need someone who can see the forest for the trees. 3-1 test. 3-1 dev, sorry. Now, the devs often build these big, beautiful trees. They love their trees. They stand back and they admire their trees. This is a beautiful tree that I just built. You built it right in the middle of a user path, right? You built it upside down. You built something that a user can't use. You built something that's too hard to use. You built something that's full of bugs and you can't see them because you're just admiring the foliage. Devs often build the wrong code. They often put it in the wrong place. They often build code that ends up getting integrated, and you find out that there's really not a great user path through it. Devs don't think like users. They think like devs. That's why we call them devs. We need somebody to think like the user. We need somebody that has to look at this forest and say, there's no path that I like. There's a path here that goes around in a circle. There's a path here that's supposed to go through this boulder. Really? And then there's a path here where I just fall off the end of the earth. The world is flat in your forest. So 3-2 test. I'm going to score a goal for test for the ability to think like a user. So now I'm beginning to understand this demand from my dev directors for manual testers. Could we have an equalizer? Of course we're going to have an equalizer. What is this? This is a forest. This is a product that's complete. Is it bug-free? No, it's bug-free because it's not bug-free for a number of reasons. It's not bug-free because we've got fallible human beings building it that are guaranteed to make errors. So there will be latent bugs. And there are going to be bugs in the test code that was trying to find those bugs. So there's going to be bugs for that reason too. And there's also going to be bugs because it's now a complete forest. And complete forests get used in different ways. Just ask Steve Jobs. iPhone 4 worked great in the lab, and then you get it in its case and in the hands of a left-handed, fat-thumbed user, and it breaks, right? There are some bugs that simply don't appear until software is built. And let me show you some just in case you don't believe me. I heard Alberto wanted to go to England, so I was planning a route for him. This is, by the way, a walking route. Was the user Jesus? I don't know. But you're going to need his help to navigate it. This is a walking route from Cambridge to Hull. Now, find this with an automated test. Find this with a unit test. You can't. Not until you get the data on the map and the software installed and the user selecting a very specific route can you find this bug. You got to have the forest. 3-3 test. That's right. We have spot A and spot B. Start, finish. 150 yards apart, which Google Maps tells you this is the shortest path. Find this with a unit test. Testicles, was it testicles? Testicles. Testicles. I'm only going to pronounce testicles that way because if I change it, it might not be good. What was it? Testivirus? Testivirus, okay. Find it, right? See, there are some bugs. He wants me to find code bugs when the software, what is his software is soft and malleable. Problem is, there are certain bugs that aren't there until it's hard and brittle. And we've got to be able to find these bugs because these are the bugs that the user will see. This is why my dev directors want manual testing. This is why my dev directors want smart human beings doing scripting and manual testing and other late cycle test engineering. Go on, automation. Find the bug. See, some of them are even hard for manual testers to find. Do you see it? Do you see it? Do you see where it says Arlington National Cemetery? Look just above Arlington National Cemetery. It's a restaurant. What are they serving? Catch of the day, cadaver. I don't know, but it's not nice to do this. You can't find this with automation. This is a late cycle test engineering problem. And so is this. Do you see it? Let me blow this one up. Copenhagen International Airport is a bridleway. That's a little horse. What are they doing? I mean, I'm assuming Denmark is fairly developed, decent infrastructure. Well, they got horses pulling their 747s down the runway. Find this early cycle. You can't. Sometimes it's the test code itself that really makes a show. This one says an error has occurred while displaying the error that has occurred while creating an error report. This is a bug in test code. At Microsoft, this was a Microsoft bug. It was found while I was an employee of Microsoft. What did we do when we found this bug? We got T-shirts printed with it on there. So I've got to give test a tie here. It's a draw. So what are we going to do about this? It's 3-3, and I really can't give another goal to either dev or test. I've run out. Right? We're in extra time. We're in penalty kicks, and everybody's making their penalties. Somebody's got to miss. What's going to give? So let's think about it a little bit differently then. If it's a draw, let's really put some thought into where we spend our money. What could we do to just fundamentally make early cycle test engineering better? I don't know. This is a really hard one. We've been talking about it for 2 days, haven't we? And there are some ideas. They're hard ideas. Everything we've talked about is hard. You know, we talk about it, the very first talk was about writing test code, and there was a concern from the audience that you've increased the attack surface of the application, right? So, you know, for every solution, there seems to be another problem every time we look really hard at early cycle test engineering. And there's another problem here. How many people are really good at this, Tracy and Russ? I can name off the top of my head, I can name at least 50 Googlers who are really good at this. Many of them work for me. And Joel, you and I are thinking of the same names, aren't we? Now, the problem with these really ultra-talented people, like we've got one on Chrome OS, man, he is an absolute Jedi early cycle test engineer. If I asked him to go work on maps, he'd be like, no. Dude, this is me, right? I live in the kernel. These early cycle test engineering skills aren't particularly transferable. They can't really be moved easily from one project to another. So I'm really hesitant to place an investment there. And then the skills are very dev-like, very dev-like. In the last 6 months, 2 of my SETs, software engineers and tests, have converted to SWEs, software engineers, right? From test developers to feature developers. I have 6 more in my tree of whatever, how many ever, 80, 90 people in my tree, who are going through the process now. So it's the very skills that we need for early cycle test engineering lead people into feature development. And that's not a bad thing. In fact, I think it's a good thing. I encourage it. That right now, oh man, this is being recorded. This is so hard. I'm going to say it anyhow. Open kimono. Right now, the best dev in my org is a SWE that was a tester before. He was a tester for 12 years. He's been a SWE for 3. Best dev in the org. All the SWEs say the same thing, right? He writes code a little slower than everybody else, but he just breezes through the code review process, hardly any regressions, never breaks the build. His stuff just works. So this is something we want to encourage. I love test skills moving to dev, far more than I love dev skills moving to test. I'm always hesitant when a SWE wants to become an SET. You got to really want to do it. You really got to tell me you have a passion for breaking things. So I'm worried about this. Not only are these people that can do this very rare, they tend to move into dev. I'm not so sure about an investment there. So let's think about the other half. What's the other half? Well, hire more manual testers. Get 20,000 people from Mozilla's and UTest's crowd to help us do this. I mean, I do like that. I like the fact that we've got a solution for this numbers game now with crowdsourcing. This makes me quite happy, and I'm going to talk about it in a few minutes. But this isn't enough. Something technological has to happen. Manual testers are expensive, and they're really not useful through the entire process. Until that code gets sort of hard and brittle, there's just a lot of prep work for them to do. There's not a lot of value to be added. We really need to be flexible with how we move these resources, these late cycle test engineering resources around our various products. So this is a problem. How do we solve this problem? If I had a solution for that, if I could take a tester and make them sort of hyper-productive somehow, right? That little helmet that Anakin Skywalker wears in The Phantom Menace, driving the little pods around. If I had one of those helmets that I could just put on and it had, like heads-up displays inside and just turning them into a Jedi, that would be cool. But if I don't have that tool, I'm not sure I can place an investment in late cycle testing either. So, what do? We either give up, stop having GTAC and all these other silly nonsense conferences and just realize we're going to be producing crappy software for decades. Yeah, users are already used to it anyhow, right? I mean, really, are you surprised when something breaks? No. I expect it to. I'm thinking, wow, I've been using this software for 5 whole minutes. This is great. Well, I am going to make an investment. I am going to put that helmet on that tester. And I'm going to see if this works. Data's still coming in, but I want to show you how I'm making my investment, how I'm spending Google's hard-earned dollars on this problem. I'm going to put the helmet on my tester, and I'm going to turn my tester into a bunch of testers. I'm going to turn a single good tester into a really hyper-productive good tester. That's what I want to do. Notice I'm not promising to turn a mediocre tester into a good tester. I'm going to take a good tester, which I believe is a plentiful resource, and turn them into a hyper-productive tester. And here's how I'm going to do it. First of all, I'm not going to ask them to do stuff, throwaway work. No more dead test plans. No more in fact, I'm not even going to write test plans. Test plans piss me off. Instead, I'm going to do test planning. But I'm not going to write a test plan. I'm not going to write test cases. I'm going to do testing. In fact, I'm going to try my best to write the minimal amount of artifacts I can. In fact, what I'd really like to do is just start in the middle. Start testing and have the artifacts be documented while I go. I'd love to do that. But that's version 2. Version 1 requires some upfront work, and I'm going to show you what that upfront work is. Now, for this to really be effective, I need to solve the problem for all late cycle test engineering, not just manual testing of a person sitting at their desk. So I've got my tester, and what I'd like to be able to do is I'd like to assign a number to that tester, right? We completed X number of testing. You know, we took it from 100% undone down to 90% undone. And then I'd like to give it to the crowd and have them not just start testing, but continue testing to be able to pick up where the internal testers left off. So that when you say, all right, how much of this problem have we solved? You know, the number goes down. Now we're down to 60% left to do. And then give it to the dog fooders to continue testing. Not to just start it all over again. I mean, come on, you guys have all run dog food programs. What happens? Every single bug you've got in your bug database, that's what you spend the first 2 weeks re-finding. Just a bunch of bug duplicates and a lot of noise and a bunch of developers taken offline to have to do this stuff. And then finally to beta. And the beta should, again, be a continuation. Wouldn't it be nice if all this test infrastructure is attached to the beta and we can still continue to monitor coverage and we can still continue to monitor new paths that have been hit, new test cases that have been, quote unquote, written. All right, so this is where I want to place my investment. And if it pays off, I got something. If it doesn't, then I'm going to go back to my 3-3 draw and think it through again. All right, are you with me? All right, so let's see what we're going to do about this. We need a way to think about software. If we're not going to write a test plan, we need a way to do test planning. And so here's our process. We have a 3-step process. Adjectives and adverbs are first, followed by nouns, followed by verbs. We're going to describe our system in those 3 terms. We're going to discover all the ways that you can talk about our system with an adjective or an adverb. And we're going to call those things attributes. Just like a human body has attributes. A human body is responsive, alive, intelligent. Now, let me just give you a little peek ahead at what I'm trying to do. I want to be able to attach tests that test for these attributes, just like you have with a human being. We have tests for a responsive human being. Is the patient responsive? Well, let's see, right? We do the little reflex test here. We've got the little light test on the pupils to see if they're dilating properly. We can take a pulse. We have tests to see if those attributes are there. So attributes are first. Second are the nouns, the parts of the body, if you will, the hand, the brain, the arm, the things that make the attributes come alive. What are the attributes of software? Well, they're the components. What are the nouns of software? The nouns of software are the components. So now we've got attributes that describe our system, components that define our system, and we're left with the verbs. The actions. What does our software do? We call these capabilities, so we end up with ACC, attribute, component, capabilities. We should be able to test that capabilities are correct and that the collection of capabilities that make up a component are correct and that they describe the attribute. Wouldn't it be horrible if you had something like Chrome with an attribute of fast? Right? When you think of Chrome, you think of speed. Wouldn't it be horrible if you went into Joel Hynoski's test team and asked the testers, all right, Chrome's supposed to be fast, right? Show me the test cases that indicate that that's either true or false. That should happen. We should be able to do it. So let's show you how we do this. It's a product that we have the code name is Testify. I don't do live demos anymore because I've been burned by it too much. So these are screen snaps I scraped before we changed its name. Turned out Testify is trademarked by some legal organization. I mean, this is definitely not a trademark you want to break. It's going to be called Google Test Analytics. Step number 1, tell the world about your product. I want, this is Google. Every product needs to be, if I can look at the source code of any of my other teams, I should be able to look at the test cases of any of my other teams. So the first thing to do is define your project, and it's world readable by default. Everybody can look at your test cases. So that, say we have two related products, apps have lots of related web applications. One web app could actually copy the test cases of another web app. Wouldn't that be nice? Second step are the attributes. This is a small sample of the attributes for Chrome operating system. It has about 14 total, and they're listed on another screen. And we come up with these on our own. We figure these out, right? How do we figure out the attributes? The best way to figure out the attributes is to watch a dev manager or a test manager or a salesperson demo the product and write down all the adverbs that they say. This takes minutes. Now, for each attribute, we attach components. Which components make it fast? Which components make it secure? And we write all these down. Now, some of these are actually automatically available. So we have like bug databases and other places within databases existing within Google that we can just pull these from and auto-populate this. We're not doing that auto-population yet. We want to do this manually to see how painful it is. But it is possible. And for Chrome OS, there's, 20 or so of these. And the third is to add capabilities, right? What does this software do? Write them all down. Now, when I first started telling people I want to do this, I want to write down all the capabilities of your application, every single one of them were like, there's too many. We can't do this. It's going to take too long. And so I'm in charge. And so they did it anyhow. What a wonderful thing that is. And we ended up with 304 for Chrome operating system. Because, a capability like play flash content is pretty broad. So I'm not asking you to boil the ocean here. I'm asking you to come up with statements about what this software does. And then we're going to test them all, or as many of them as we can and in many different ways as we can. And we're going to know how many test cases played flash content and which component that's in and which attribute it describes. And we've created all those. When we went to the dev team and said there are 304, they were aghast. So they reviewed it with us, and it turns out we were wrong. There were 314, I think. And then they believed us. Now, we end up with the numbers here, and this is just a small section of it while it was still, I scraped all these out while it was still in development. Next thing we do is we prioritize these. So we've got 314 capabilities. Which ones are more important? Now, coming up with risk numbers is really not scientific. How do you do it? What are the most risky parts? Well, certainly any capability that kept it from performing one of its key attributes, they would be really high risk. So if you have a capability that has to be fast, that's got to have a high risk number. If you have a capability that has to be secure, right, like, Chrome operating system, a capability would be that we time out after inactivity, right? If that's broken, that's really high risk. So we just guessed. What is this, Oz's rule from Usenix? If you don't know the answer, take a guess to a bunch of experts, and they'll tell you you're wrong. But if you go to them and ask them for the answer, they'll say, I don't know. So we guess. We come up with a bunch of risk numbers, and then we take them to the devs and say, hey, this is the order in which we're going to test your stuff. And they get real interested all of a sudden, because devs have a different view of risk than we do. If you ask a single dev, they're going to tell you the stuff I worked on is the riskiest part, please test it the most. If you ask a sales guy what's the riskiest part, they're going to tell you the part that I have to demo to customers is the riskiest part. Please test that the most. So we don't know how to do this. So we guess as testers, and that guess forces the hands of all of our partners. And we put in numbers and we average them and we get something. Something hopefully is better than nothing. And we won't know if we're wrong for many, many months. We've got to do this project after project after project after project. We need to do this. So eventually we'll understand, okay, we were wrong and we were wrong this way and we can fix this. So maybe in March, if I give another talk, I will have some data about that. So those are the risks. And I just color-coded them red, yellow, green. So here's how it all stacks up. This is a visualization that the tool provides. This is basically for all of the, and this is, I think this is all the attributes that we have, or all the, no, this is a subset of the components. This will show you basically the test volume of each of those components. This is how much testing has to be done. The number of capabilities that need to be tested per component. So now you can do a little resource planning, you can figure out, okay, this is going to need more testers than this, and you can do some preparation. This is the part of the application that requires testing. And so the mountains require more testing than the valleys. If you don't like to look at it that way, you can flip it upside down and you can think of pouring test cases into these holes until they're full. Or you can look at it this way as a spiral, where the highest risk is the center of the graph, lowest risk is the outside of the graph, and you can see which of these circles you have. How many test cases does it take to push one of these circles from the inside to the outside? If you want to know what one of the circles is, you can click on it and it'll tell you which capabilities, how many test cases are associated with it, etc. You can also pivot on smaller number of points if you're only interested in a few of the attributes or a few of the components. And those arrows indicate the direction that you want to go. So these are time-lapse arrows. This is where we started, we did some testing, and this is where we are now. Our risk is going down. You with me? Okay, so this is a setup. This is what we want to do. This is what I'm investing in. I think this is a good idea. I end up with an application called Google Test Analytics that contains all of my test planning information. There's no test plans in there, but everything I need to test is described in this tool, and I can maintain it. See what we need to do? Devs have a huge advantage. They have no choice. They cannot have dead code. The code is always alive. The code is always up to date. In test, we have this ability to just let our stuff die because really the code's the only thing we ship. I'd like us to maintain this. I'd like to make it as easy as possible. I'd like to automate as much of it as possible. I'd like to drag a lot of this stuff in from the environment if I can. We're working on it. But this is compelling to me, and it's working for me. Now, how do I go about testing? The thing that, once I figured this out and we started doing it, and it started working on client and YouTube and some of the other places within Google that are using it, it became clear that we still weren't really helping testers be better. We were just helping them be more organized. So that's the second part of this. How do we help testers be better and do a better job of testing? How do we take that good tester and amplify their effort and amplify their productivity? So I take an inspiration from gaming here because I think the gaming world has it right. If you think about what does a tester have to do? There's a lot of information a tester has to consume while they're testing. There's a bug database. There's a source database. There's a source code review database that testers check all the time to see if these things are actually worth testing. There's test automation. There's test case databases, right? Test case management systems. There's all of this information that a tester has to run around and figure out. You know, how much time... I actually started asking every single tester in my org, how much time do you actually spend fingers on the keyboard testing or fingers on the keyboard writing a script that will test? Writing test cases, whether they're automated, scripted, or manual. How much time do you actually spend doing that? After I got to the fifth person, I was so depressed I decided I was going to cut my survey short. My boss likes data like that. Data like that depresses me. It was clear to me that testers aren't spending enough time actually testing software. They're spending a lot of time doing all this other stuff. Just stopping testing, turning around, going through and finding your bug report, writing the bug report, making sure the bug report's really good, really accurate. What version of it am I running? What operating system do I have? What version browser? This takes time. And chances are you've just produced a bug report that someone else has another bug report for because we've got 18 duplicates in our bug database for this. Not only has this taken a lot of time, it's all been a waste of time. So what can we do for that? Gamers got it all figured out for me. I didn't even have to invent this one. What do the gamers do? Do gamers spend a lot of time trying to figure stuff out? Do they have to read the game user manual to figure it out? No, all that stuff's displayed for them. It's called a heads-up display. Does a gamer, you're in Halo and you're going through, do you have to figure out what weapons you have in storage? If you're in World of Warcraft and you're a wizard, do you have to figure out, oh, let's see, do I have Fireball or was that magic missile? I don't remember. Pause the game and go check. No, it's all there on your heads-up display. Every spell, every weapon, every capability. There's a mini map in the upper right-hand corner to tell you where you are. There's all of this help. You can hover over an enemy to see what their health and power is so you know whether to attack them or not. That's what I want. I want you to the gamers spend all their time gaming, and the testers are running around looking at all this other stuff. So now I want to take the bug database and I want to surface it on the screen in a heads-up display. I want to take the source code and I want to be able to surface it anytime you see it. I want to take every single piece of information that takes you away from testing your application, and I want to overlay it just like this heads-up display. That's what I want. If I could do that, I think it would be very impactful. Now, there's one thing that gamers do. There's one thing that they have to look at. There's one thing that stops the gamer in their tracks. And I know this because I have a 13-year-old son. Xbox is upstairs. He'll come whipping down the stairs, flick on the Mac, and start looking for game cheats. It's like, I got to figure out how to play this level, right? And there's two things he's looking for. He goes to YouTube to look for videos of other people who've beat the level. And he can just watch them. He's like, oh, that's how you beat that hobgoblin, right? And it whips back upstairs. He's like, don't turn off the Mac. Yes, son. And then he's up there, and I figure, I could tell him that it's actually all internet enabled up there, and he could, but I just kind of like him to get the exercise. So now you don't even have to do that. You got the cheats. I hope you can see this well. I've got another one. But the upper left-hand corner is a look-ahead radar. It's a cheat, right? And it's in the same vein as everything else. It's pulling information, except this time from the game illegally, because all that information is cached on your Xbox. So it pulls it out, right? See the little red squares? Those are bad guys waiting to be spawned as soon as you go in those rooms, because it's all cached right in your memory waiting, right? And so you can do some really cool things. The blue are shields around people on my team so I don't accidentally shoot them. The red are bad guys. This is a hack we did while I was a Microsoft employee. It was live on Xbox for a while. We were trying to figure it out. So what we did, instead of trying to figure out how people were cheating us, we just wrote better cheats than them and then figured out how to stop those, right? So why debug their cheats when it was really fun to write our own? And my son was a tester on this. The day I came home and said, I've left Microsoft, I'm going to Google, the poor little lad cried, right? He said, what about my Xbox cheats? It's a simple world when you're that young, right? So can I get this too, right? Can I cheat? Can I make myself more powerful than just a regular user by surfacing information from the application itself? There's cheats all over the place, right? This is such a useful, common thing that it's implemented in almost every game you can get, right? Heads-up displays and cheats. So maybe we can learn something from these video game guys. Maybe there's something here. There's something to this. All right, are you with me? I mean, is this worth investing in? Is it worth pursuing? Or should we just stop right now and call it a draw? Proceed. Okay, thank you. So let's proceed. Whoa. So here it is. Not quite as sexy as the video game, but I'm testing Chrome Extensions Gallery, and that's my app. The heads-up display is in the upper right-hand corner, and you'll see it's got journal, bugs, flux, which I'll talk about in a minute, and a map. The map will crawls the code and builds a map of your application for you. It knows about the components, maps those components to the components in the ACC, all is well. The journal is your log, right? It's your mission log. You're going to do some testing, and we're going to record it. This is another thing that really maybe I should have take a goal away from the testers because this pisses me off too. We just got through review cycle, right? Anka and I were sitting around having a beer last night and complaining about this very scenario, right? How do you judge a tester? This is what we were trying to figure out over beers. And he's like, what do I have? I don't know a lot of these people. I don't know their work. All I can do is sort of look at what code they wrote and look at what bugs they found. And it's very unsatisfying to judge somebody on that. This person may have written, 1,000 really good test cases that validated really complex scenarios and showed that there's no bugs in them. Really valuable work. But all we've got credit for is the bug. I hate this. So I want to be able to take credit for those 1,000 really good scenarios, so I'm going to record everything. And I'll show you a little bit of what we record later so that not only can we reuse these test cases, we can take credit for them as well. So what I'm going to do here, you see in the heads-up display, hopefully it's big enough, I'll just interpret for you. It says you're going to perform a bad neighborhood tour. So this is part of the cheating. Just like my son goes down to YouTube and watches someone else better than him try to finish a level, and then learn from that and go upstairs to the Xbox and do it himself, we've done the same thing. We've taken test wisdom. We call these things tours. It's in the 4th book, Exploratory Software Testing. Damn, I just proved Alberto right. I'm here to sell books. Egad. It's wisdom that we've learned over the ages, right? So the bad neighborhood tour is the piece of wisdom that says, the bugs tend to hang out together. If you found one bug in a component, there's probably another one, right? We've known this for decades. We don't know why, but it's very wise to test there. And so we do. So a bad neighborhood tour goes through and says, okay, we've got all these components, extensions, most recent, search results, most popular, etc. And there's 3 of them that are marked red, meaning they have had the most bugs and they have outstanding bugs right now. And so all you do is click on extensions and you're taken to the extensions. You don't have to navigate there. The tool will take you there. It already has figured out the structure of this application. And now you click that and it takes you there and you see that there are 3 bugs here. 2 red bugs and 1 yellow bug. You also see those bugs are overlaid. They have a little cellophaning overlay to them. The red bugs are bugs that have been filed, but the dev hasn't fixed them yet. How do we know that? Because I told you, we just drew all this information out of the bug database. We are totally aware, completely aware of every bug against this app in the bug database. And we show you where they are. So now, if you look at one of those red ones, you think, well, there's already been a bug filed there. Certainly, you're not going to file that bug again, because you can hover over that and you can get information about that bug. So if you have found another bug there, you can make sure it's been distinguished. The yellow one, you might want to go ahead and validate that. That means it's been filed, it's been fixed, a fix has been checked in, it's in the build, ready to test. There's no test cases that have run through that area yet. And so you could do that, or you could file another bug, some stuff we stole from feedback. Say you found a bug there, you've got these little crosshairs and you identify it, you click on it and say, okay, I want to file a bug. Now the tool pulls up the information about that control to help you identify it. This is the control. Is that the bug you want to file a bug against this control? Yes, I do. Okay, now you can do 2 things here. You can type in information about the bug, or you can let the tool do it. And the tool knows where it's been, it knows how it's got there, it's recorded everything you do. It'll be happy to put that in there in either English or JavaScript. Now you can have some choices. You've got a video recording that we've been doing in the background. You want to attach that? Yes or no? Screenshots of everywhere you've been from the time you started the application to the time you found this bug. Help for debugging. A Flux log, that's a JavaScript recording of everything you've done, so you can actually replay it. The developer can just click the link in the bug report and have it replayed for them automatically. And then a DOM dump. It turns out the series of changes to the DOM, we're quite interested in this. The series of changes to the DOM is the way that a lot of developers debug web apps. They look at the DOM, they look at what happened to the DOM as they run this test case. So we're trying to figure out, maybe there's some patterns there that we can just file bugs automatically when we see those patterns occur. So that's a little 20% project that me and one of our guys are working on. So now we've done that, It automatically detects what versions of all the relevant software that you're doing so you don't have to guess. Yes, users do enter this wrong. And the bug has been filed immediately. It's already in the bug database, and we've turned that control red to let other testers know. All testers are going to see this same heads-up display when they're testing the app. And then the journal will tell you what you've done, where you've been, how long you've done it, and all that stuff is stored so it can either be replayed or you can take credit for it. And then you can go back to your map and you can click on something else and continue on your merry way. You with me? There are a few other capabilities of this tool. There's a bunch of tours that we've implemented. Tours are basically collections of test cases of similar form, and they'll guide you through it. The journal there, and then you've seen some of those. If you hover over those squares, you get information about the bugs. You can click and get more information if you'd like. And then there's a historical record of the testing that you've done on this application. This is what the scripts look like. This is we've done a bunch of JavaScript recordings of common YouTube scenarios, and we play them against every build. Some of them break because UI changes. We throw them away, re-record them. Somebody's building a tool now where it will play the script until it breaks, and then it'll give you a little editor, and you can try to fix it, or you can just go over and start the script from there, so you don't have to repair it all. Or we record it in as good of English as we can figure out. We're associating these JavaScripts with more English-oriented versions of it. That's what we're going to do. That's what we're doing. This tool has been, the current form of this tool is that we have it. We're dog fooding it with, I think we're up to about 8 projects now, and UTest has it. And UTest has done one project. What we did with UTest is we gave it to 10 testers. We hired 20 testers from the crowd to test the same thing. 10 with the HUD, 10 without the HUD, and we're still collecting the data to see how we've done. So now, if this works, if this is a worthy investment, then we've got 4.3 tests, and we're going to have people do this. So how do we get people to do this? Well, we're committing to open sourcing this. Open sourcing as much of it as we can. You realize that as an internal Googler, I've got access to infrastructure that is very hard to export. So to the extent that we can open source this, we will. Right? So for right now, it runs as a Chrome extension, and the Chromium project is completely open source. So as long as you're testing within Chrome and using those bug databases, et cetera, you're totally fine. My new friend Matt from Mozilla and I spent a day together at the fort, and we have a gentleman's agreement to share a source and figure out how we can get this in Firefox. And my old friend Sam from Microsoft is we have a gentleman's agreement to get Internet Explorer to look hard at this too, so that the 3 browsers can share source code and try to get this implementation in all 3. So we're very near to the point where we're going to announce this and give it out to others. So stay tuned. The Google Testing blog, googletesting.blogspot.com, is when and where we will announce it, when we will announce it, hopefully before the end of this year. Okay, so if we succeed here, what we've done is we've got a tool that stores the record of our testing. Now, what I want to do with this tool is I want it to maintain itself through manual testing inside of Google or in your company. And then when we hire the Mozillas and UTest crowds or Satyam crowds or whoever else is doing crowdsourcing, it would continue on, right? The tool would understand, okay, there's more testing going on. This is a cumulative effort. Same thing with the dog fooders. I would like my dog fooders to see those little overlays to know where the bugs were so they don't bug me with new ones. Finally into beta, and then the HUD can be stripped by simply taking away the Chrome extension. It's that simple. I'm not introducing any new code into the app at all. if I can do all that, I think we really do have a situation where we've got 4.3 tests, and this will be a worthwhile investment. So if you're interested in this, follow our progress. We're going to start blogging about our experiences using this tool on googletesting.blogspot.com. We're going to be really open and honest about the parts that don't work and that we throw away. We're going to be really open and honest about the researchy and cool stuff we want to do. Maybe you can help. We're going to release it as soon as we think it will do more good than harm. And that's it. I hope I have succeeded in turning quality on its head. And now, I know everybody's expecting some statement about Alberto. This is my wish. My wish is that next year at GTAC, he gets invited to do a keynote, and I get invited to do a video. That is my wish. I'm James Whittaker. I'm from Google, and I'm done. Thank you. Questions, please, that I can answer, preferably.
Hello? Yeah. Thank you, James. That was a fantastic talk, and that's why I'm standing up.
I like you already. Okay, anybody else have a question?
So, is it fine? Okay.
Yeah, it's you.
So, 3 things that I noticed in your presentation. First thing was ripping test plan. Agreed. Then you said empowering the testers to be hyper productive and providing them some sort of helmet. I think Testify was that helmet. Testify, as far as I understood, is again planning around risk, and that will take same amount of time as creating a test plan document or a Word document. Isn't it the same thing? Means planning around the risk, that time tester will not spend time on testing. He'll be planning around risk. He'll be providing some numbers to test scenarios at whatever level we find comfortable with. So is Testify early life cycle tool or late life cycle tool, or is it throughout the product life cycle tool? First thing. Second thing, isn't it a new sort of test planning with the Testify?
Okay, so Testify is our internal code name. We're going to be calling this Google Test Analytics. Now, so the first question is this a late cycle or early cycle testing? So here's how we do it now. So on Chrome OS, we've actually been using this in the early stages when, according to Alberto, the software is still soft and malleable. And it's hard, right, because it's difficult to keep it up to date. It's the same exact problem as people have with test plans. I'll be perfectly honest with you. However, it really gives you a running start to the point where the software does begin to dry out and become crispy. And so for example, a lot of my products and client will get to a part where complete code freeze. So if I wait until code freeze to start doing this, I've waited too long. So I need to be test planning and executing while the software is still soft and malleable. But at the point at code freeze, I want my ACC to be complete. And I want to just go all out sprints on doing testing. So we use it through the whole process. It's most useful late cycle. I used to call this talk late cycle engineering until I changed it to turning quality on its head. So I see it as both.
I got one thing.
Hey, my Turkish friend, what's up, dude?
Well, you got a bug.
I got a bug?
Yeah. I come from the only country that works like an American investment bank, and that's not Turkey.
You work in Turkey?
Nope.
There was a turkey in there somewhere, wasn't there?
There's a Turk in here, but it's not me.
Oh, okay. All right. So
You owe
my
me
Greek friend.
You owe me a T-shirt.
Man, never piss off a Greek. I will send you a T-shirt. You want this one? Thanks for that correction.
So with this tool, have you observed like the Heisenberg's effect, that just because you're monitoring so many things, that in itself creates more issues, especially performance related?
Wow, I don't even think I can spell that. Your performance isn't an issue with the tool. It's lightning fast. It runs as a Chrome extension, and it does a lot of stuff in the background in advance, so that while you're running test cases, we haven't noticed a lot of latency. And in general, you'll be in one area, right? Like when you're in the bugs tab, we're really only interested in the chromium.org bug database at that point. So it has not been a problem in our trials as of yet. You know, YouTube's probably been I mean, all the client stuff is way further, but YouTube has been, there's a lot of test cases there. And, you know, we throw the ones away that break. We record new ones easily. The recording process is really fast. So we haven't noticed a big problem, but we are watching for it.
Hey, James. Hey, I'm over there.
Oh, hello,
Yeah.
Marcus.
Hey, so I have a question about this whole forest wood tree thing in the beginning. I actually think the examples you brought with the Google Maps are, for me, a classical example that should have been found by a small test in the development cycle. But that's a different point. The point is, I see that we need to test, and I know that we need to make a huge effort, but I think the real effort should go into getting our products to a level where they actually don't need testing anymore at all. So I'm thinking of, I'm building a house, which is an engineering feat just like writing Google Maps. But nobody afterwards comes with some complicated equipment to test the house. There are no house testing conferences. How do you think we can actually get rid of the need of testing in first place?
So I would, first of all, argue that building a house and writing software are two completely different things. Building a house is way easier. Boris Beiser wrote a famous and I think brilliant paper many years ago about arguing that software engineering is harder than anything, right? Even putting the space shuttle in the air, and he makes a very convincing argument for it. So, but houses break all the time, man. I built 4 of them, and it's in a constant state of broke. So, so I don't think, I'll argue your analogy, but you know, people have been trying. I mean, really smart people have been trying. Harlan Mills, clean room software engineering, back in 1984, right? That was probably the best attempt. The reason he called it clean room, right? Clean room, you design hardware in a clean room where bugs never exist. You know, the only bug-free software will be software that never has a bug to begin with. This is a really hard problem. We've been working on it for a really long time. I don't see us making a lot of progress. So maybe this is a stopgap. Maybe there's some future in which we don't have testing conferences anymore, but I don't think I'll live to see it.
Okay, let me put it different. So we've seen basically 2 kinds of talks today and yesterday. We've seen half of the talks telling us how to make software better, and half of the talks telling us how to test software better. Now you're in a position where you're actually allocating resources to one of the 2 things. How do you think is the right trade-off?
I think the right trade-off is the status quo on building software better, because I tried to make the argument that progress there is going to be limited because of the number of people that are capable of doing it, Tracy and Russ, and that there is a lot of benefit to be gained in late cycle testing, because I disagree with you. Those maps bugs require data to be found, right? And that data changes on a monthly basis. They're sucked into the maps constantly. So there are a certain number of bugs that will be introduced after the software is built, by definition. So we're going to be having test conferences for probably decades, certainly decades, probably centuries. And in fact, I'm not sure it'll ever be solved. Humans are fallible, man. Can't take them out of the equation.
Hi, James. This is your new test buddy, right?
Hey, man. Good old Matt. Man, you take some good pictures.
Oh, glad you liked them. How does this tool handle like a session, or is there a pause and resume on this tool so that it, you can just go home and resume later when you come back the next day?
So a session meaning a contiguous part where you're just testing. I mean,
Yeah.
it's like there is no pause. You can just pick up completely, just like a video game. You stop playing, you pick up, you can either run a new mission, save your old mission, run a new one, or you can continue where you left off.
Okay.
Now, hopefully, you're doing this as teams. We like to, the funnest part about the HUD, particularly the heads-up display, is doing this in teams and watching, 4 or 5 testers working on machines and having this stuff updated updated in real time. It's actually pretty cool. So so in that sense, once somebody leaves, the mission's over. Just like an Xbox game, some kid's got to go to bed. You know, the game's over because you've just lost a player.
Great, thanks.
James, this side.
I'm glad you all raised your hands because it seems like someone from above is talking to me.
Okay, so my question is around the noun, adjective, and adverb technique. So beyond that, there was some research done called extensions to noun-verb techniques, which gives us questions, and then to organize those questions in the form of shareable test ideas across teams and organizations. There was something called questioning patterns, Q patterns, which is patented by Vipul Kochhar.
Yeah, Q patterns, there's goal question metrics. I mean, there's lots of stuff out there on this.
So are there similar measures taken at Google to share test ideas by stripping off the domain part of that, making them generic, and then sharing across teams? What kind of initiatives do you take there?
Well, for us, within my teams, so you know, this is all pretty new stuff. And sharing this, you know, every single test director, peer of mine, is ready to use this, but they want to see it work, right? So we're all kind of starting small. Tours are really our mechanism for sharing test wisdom. We don't call them patterns. We call them tours because that's what I called them in the book. It seemed to make sense, right? You're visiting a city and you want to make good progress, and that's how you organize your thoughts. We could have called them missions. I think missions is kind of cool. It's more military. But we try to group it in something that makes sense. So here's how I knew, you know, back when I worked at Microsoft, I was walking down the hall, and there were two people around a corner, and they were talking about the landmark tour. And I thought, hey, that's cool. I invented the landmark tour. Here are two people. I'm going to walk right in between them, you know, just kind of sashay in between them, and they're going to go, oh, wow, there's the creator. And I sashayed in between them, and they just kind of stepped aside and looked at me like I was rude, and then continued to talk about the landmark tour applied to Visual Studio. They didn't even know who I was. That was really, to me, I walked away with a big smile on my face because I thought I've succeeded, right? We've taken this out, and it's sort of virally gone through the company. Microsoft has tours now in their courseware that Alan Page runs on behalf of the SDETs in the company. So that's kind of the idea, right? Because the tours do make sense. The landmark tour, once you learn it, you can tell a tester, run the landmark tour, and they will know the exact set of test cases to run, no matter what the application is. So it's a way to talk about testing. And it's in my fourth book.
The root cause you cited was, at the beginning, was code. Code is complexity, and we hire devs to write code and testers to write more code. If the problem is code, perhaps an alternative solution is to hire people whose explicit job it is to delete code and to clean code up and reduce complexity.
You sound like Simon Stewart.
Have you?
Simon's on the way over in the airplane. He comes over to me and he sits down and he says, I want to talk to you about deleting code. Right? I want to figure out a system where we can pay people to just rip code out of Google 3. That's our stuff, right? And you know, so it's this big grand idea, and it's a great idea. I'd love to do it. I think we ought to milk our peer bonus system for this, right? You don't get paid for writing code, you get paid for deleting code. I'd love it, Simon. Let's do it.
Okay, thanks.
But really, the problem gets back to complexity. I mean, Marcus's idea that we can build this is wonderful, but software is hard. And human beings, fallible human beings are doing it. And we continue to do the same stupid things. You know, I've worked for a lot of companies. As a consultant, as a full-time employee, I see the same stupid things in the halls of all these companies. Until we get to the point where we stop doing those stupid things, we're going to continue to be talking about this. And even then, it's still hard, and we're still fallible human beings. So, I mean, we either start, you know, collecting DNA from Tracy and Russ, or we continue to struggle. But I'll tell you what, Marcus, you figure it out, turn it into home building, I'm not only buying you a beer, I'm buying you a keg.
James?
Yes.
Here, James. This. Back.
Whoa, I see a bright light.
Here.
Yes, sir.
So you mentioned that you're making this helmet for a smart tester, right? What if it becomes overhead, right?
Helmet, it's kind of over the head is sort of.
Yeah. There's somebody who's advising the guy. There's somebody who's keeping an audit trail of all the activities that he's doing, and somebody who's expecting that smart engineer to follow the advice, based on certain scores or metrics, which he may like to question, or he may like to take a different path. So don't you think that this is kind of a information overload, or that's kind of a expectation that that complements his style of work?
Okay, so the two parts to this answer. The first part is we're not controlling the tester. The tester's going where they want to go, right? They can ask the HUD, take me to this component so I can start testing, or they can go there themselves, right? So there's no fences that they have to climb in order to go where they want to go. Testers are completely and totally unleashed. The second part of it is you just turn it off, right? If there's a part of the HUD you don't like, just like in a video game, if you walk into one of these internet cafes and everybody's playing the same game, all their HUDs are going to be different. They're going to customize it for themselves based on what kind of help that they need. So no shackles, no fences, and it's fully customizable.
Okay, so I just wanted to put a point out there that we are 50 minutes over and we're eating into our break. So if there are more questions, we can continue on and get a chance to have James address them, or we can take a break now and you can find him later on.
Let's take a break, but before we take a break, did you all like the chalkboard? That was so that's in Presently. That's Google Presently, believe it or not. And some of the people that work on this product were going, that's Presently. So a guy on my team, Joe Allen Maharsky, and his wife, Terry Maharsky, are the artists behind this. So I just wanted to shout out to them.
All right. I just wanted I wanted to thank James for all the excitement that he brought on, and Alberto that tagged him along. So.
And if you invite me back to India, I am going to have a smile on my face when I say, yes, I'll come.
That is a great change of heart. So we would expect that to continue on. Thank you, James.